Good day, everyone. Today I'll be presenting my study entitled Substantiating the Potential of Biochar to Mitigate Global Warming in Rice Agroecosystem under thesis dissertation category. The use of biochar as an amendment to effectively improve the quality of the soil has been gaining wide acceptance all over the globe. As evidence in this figure, we can see an increasing trend in biochar sales expressed in million US dollar. In fact, it is projected that this increasing trend would continue for the coming years. For that matter, the biochar technology as an organic amendment in the soil has demonstrated its effectivity based on a meta-analytic study conducted by Liu et al. In 2016 regarding biochar's effect towards improving soil's organic carbon content. As we all know, that soil organic carbon level could tell us the overall quality of the soil. Hence, biochar is recommended by many researchers as a means to increase the soil organic carbon level and in turn mitigate global warming. However, it is important that organic amendment, including biochar, be assessed in its environmental impacts when utilized as an amendment in soils. A cradle-to-grave analysis or life cycle assessment technique aims to assess the environmental impacts associated with all the stages of a product's life, which is from raw material extraction through materials processing, manufacture, distribution, and use. In order to evaluate the overall impact of biochar as an amendment, there is a need to completely evaluate the flow of carbon. The evaluation should be complete and that constitute during its production process and utilization process. Most of the biochar studies did not account the global warming impact during biochar production process, which is why it is hypothesized in this study that very high amount of greenhouse gases could be emitted during biomass feedstock combustion. Here are the hypotheses of the study. First is that during pyrolysis process, significant amount of greenhouse gases could be emitted as the product of biomass feedstock combustion, and that the emission rate is governed by temperature. Second, the net global warming potential of biochar in whole system boundary could be markedly lower compared to other organic amendments like raw and compost manure due to the possibility of recycling the greenhouse gases emitted during pyrolysis process. Here are the research objectives. First is that to investigate the amount of greenhouse gases emitted during biochar production processes. Second is to examine the impact of biochar in methane nitrous oxide emission during cropping and fallow period. Third is to estimate the soil organic carbon stock changes by a net ecosystem carbon budget using heterotrophic respiration and harvest removal. And fourth is to identify the impact of biochar on net global warming potential in cropping system boundary using the greenhouse gas fluxes and soil organic carbon stock changes, and to determine the net global warming potential for biochar utilization in whole system boundary that includes from industrial to cropping processes via life cycle assessment. The main biomass used in the study is swine manure swine manure, where it was air dried in a greenhouse, oven dried for a day at 80 degrees centigrade and sieved using 5 millimeters sieved opening and mixed with sawdust at 30%. The chemical properties of the manure is shown in this table. For the pyrolysis process, for biochar production, feedstock was loaded in a muffled furnace, pyrolyzed under closed condition at 400, 500, 600, and 700 degrees centigrade. The heating rate was at 10 degrees centigrade per minute, and biochar was sieved with 2 millimeter opening after the production. For the treatment installation, field experiment was done in this study in a typical rice paddy in South Korea. Table 1 shows the chemical properties before the field experiment, and the table 2 shows the chemical properties of the manure treatments which are biochar, compost, and raw manure. Now, compost and raw manure were selected as amendment in order to compare with biochar. They were applied in uniform application of 12 milligrams per hectare and a chemical fertilization of 90-45-58 of nitrogen, phosphorus, and potassium. For the investigation of greenhouse gas fluxes, closed chamber method was used, wherein methane and nitrous oxide were the target gases. Sampling time once a week for 30 minutes, and for the gas analysis follows gas chromatography. And the greenhouse gas emission was calculated with this formula, and for the seasonal greenhouse gas fluxes was calculated using this formula. In here we can see for results, we can see here that the composting has higher emission rate, total emission compared to pyrolysis. However, in the case of pyrolysis, we can use different kinds of temperature. In this study, 400, 500, 600, 700 degrees centigrade for temperatures. Now, in this case, we can see that the higher the temperature, the higher would be the greenhouse gas emission. In the case of pyrolysis, emission of methane and carbon dioxide could be recycled or could be removed from the system in order that it may not be emitted towards the atmosphere. These are the following pathways that could be used in syngas recycling. We have the dry forming reaction, reverse water gas shift reaction, and Bordeaux reaction, leaving only nitrous oxide because there's still no way that nitrous oxide be recycled in the system. Now, for the cropping process boundary, the calculation of the net global warming potential, that was the methane and nitrous oxide emission, and the SO stock changes. For the methane emission, we can see here the emission rate of raw manure application, followed by the compost, and for the biochar. It is very clear and very evident that the biochar had the least methane emission during the cropping and fallow season, where it is 67 and 56% lower compared to raw manure and compost. For the nitrous oxide emission, raw manure emitted very high amount of nitrous oxide, followed by compost and biochar, wherein biochar was 51 and 36% lower compared to raw and compost respectively. For the net ecosystem carbon balance, or for the SOC stock changes, total carbon output minus the total carbon input. For the total carbon input, that includes the total carbon input of the above ground, the root, the litter, the rhizome deposit, and the manure amendment. For the total carbon output, that includes the harvest removal and heterothermic respiration of carbon dioxide and methane. Now, to subtract the total carbon output to the total carbon input, what will be left is the SOC stock. So in this experiment, we can see here that biochar had the highest soil organic carbon stock, which is 57 and 13% higher compared to raw manure and compost application respectively. However, there's no significant difference between compost and biochar. For the calculation now of the net global warming potential, wherein the methane nitrous oxide emission were converted in their carbon dioxide equivalent form together with the SO stock changes, then this SO stock be subtracted from the greenhouse gas emission. So that would lead into a negative emission for biochar, meaning to say that the application of biochar converts rice paddy into a greenhouse gas source instead, into a greenhouse gas sink instead of becoming a greenhouse gas source. However, there's no significant difference between raw and compost application. Combining now the industrial and cropping process boundary, and here we can see that very high amount of emission are coming from compost, because compost added, there is an additional greenhouse gas emission during the composting process, which is very high. However, in the case of no syngas recycling biochar, it has no significant difference with raw manure application, meaning to say the impact is just the same. But with syngas recycling system, this effect of biochar would be more pronounced. It is more evident if the syngas is being recycled. And for the grain yield, we can see here that there's no significant difference among them, but compost was significantly higher compared to raw, resulting to a greenhouse gas intensity, which means that it is the global warming potential per unit grain yield. So from here, the raw is not significantly different with biochar under no syngas recycling, but with syngas recycling system, it is significantly the lowest among them, which means to say that with syngas recycling system, it increases the effectivity of the biochar to mitigate global warming. As a conclusion, biochar is more functional than compost to mitigate methane and nitrous oxide emission and to increase soil and carbon stock in rice paddy. During biochar production, lower pyrolysis temperature is recommended due to lower greenhouse gas emission. Third, in biochar soil system boundary, almost 100% of greenhouse gases were contributed by industrial process and not by cropping process, owing to a net negative global warming potential in rice paddy. Lastly, compared to raw manure, biochar utilization produced under without syngas recycling would have similar impact. Otherwise, with syngas recycling, biochar is more significantly effective than raw manure application to decrease net global warming potential. That's the end of my presentation. Thank you for listening.